Welcome to this first Select AI office hours of 2025, entitled Getting Started with Select AI. Enterprises and individuals are both finding compelling and impressive ways to apply AI. And while there's a lot of value to be derived from chatbots by the leading AI providers, whether it be Cohere, OpenAI, Anthropic, Google, and others, they can come up short when answering questions on your specific data. And that data can include private and enterprise databases, but it can also include unstructured text residing in object stores and the broader data lake. So in this session, we'll introduce you to technology that can help you derive more value from your data, and in combination, generative AI. And if you haven't already considered registering for this office hours series, try using the QR code shown here. So I'm Mark Hornick with Select AI Product Management, and I'm joined by Sherry LaMonica. Sherry?
Hi, everyone. I'm Sherry LaMonica in the Oracle Machine Learning Product Management team at Oracle.
Okay, so this is Oracle's safe harbor statement, since we'll be talking about some of our roadmap items later in this session. For our agenda, we're going to start with a brief introduction of Select AI. We'll look at natural language to SQL generation, highlight a use case involving generative AI directly, explore retrieval augmented generation and synthetic data generation, and we'll wrap up with a summary of some of our latest new features and our roadmap. So Select AI allows you to develop applications using generative AI, specifically large language models and transformers, doing this easily using SQL and PL/SQL. Select AI originated as a component to generate SQL from natural language questions or prompts using metadata from tables in your database. Now, we first launched Select AI for Autonomous Database 19c and then 23AI. And just recently, we released Select AI for non-autonomous database instances with 23.7. I'll say a little bit more about that later. But in addition to SQL generation, Select AI allows you to leverage GenAI more broadly to develop applications involving things like email generation, recommendations, sentiment analysis. And Select AI serves as a developer assistant for generating SQL that's specific to, that is runnable on, your database. And this helps SQL beginners as well as SQL experts who are looking for productivity aids. Now, another popular use case involves building applications where end users can interact with their data using natural language queries in a variety of languages. And since Cloud World last September, Select AI expanded what's possible with support for retrieval augmented generation, commonly known as RAG, to work with unstructured data from knowledge bases and support generating data, synthetic data generation. Now, a key enabler of Select AI is the large language model, or LLM. And there's been a lot of coverage of LLMs, and I suspect that everyone on this call has not only heard of them, but likely also used them. Now, we know they're good for generating text content for tasks like answering questions, extracting information, generating code. But what happens if you ask an LLM about listing your top 10 customers by revenue? Or what is your internal corporate policy on a given topic? It's more than likely that the LLM won't be able to answer these types of questions in any meaningful way. And this is where Select AI comes in. Now, as you may have experienced, LLMs are not without their issues, which can include things like hallucination, bias, and other limitations. Hallucinations occur when LLMs produce a confident response that seems reasonable, but is simply not true. And this might happen when the LLM doesn't have enough context or hasn't been trained on material relevant to what is being requested in the prompt. Now, in other cases, also related to training data, is bias. For example, one can't expect an LLM to answer questions accurately if it doesn't have experience, that is, the training data in that area. Like, what if you had training data that contained articles on physicians and the text mentions only doctors of a single gender? Well, we can't expect the LLM's responses to reflect anything but this. And there are temporal limitations as well. The LLM can only know information up to its training day. And of course, it has no knowledge of your specific business or enterprise or your private information, unless, of course, you explicitly give such information in your prompt. Now, although less of an issue with many of the newer LLMs, models also have token limits. Think a number of words that you can supply to it, both in the size of your prompt as well as the output that is produced. Well, Select AI can help address such issues. Now, to make this a little less abstract, we'll show a simple chatbot built using Oracle Apex with the option to interact with the LLM alone or to have an augmented prompt using a database. Sherry?
Okay, so this chat app was built with Oracle Apex. It's built on Select AI, and it's a very simple and efficient way to get answers from your database. Just start asking questions. So the first question I'll ask is, how many customers do I have in each country, and place in descending order? And I'm not asking my database, I'm going straight out to my AI provider, the LLM, to ask this question. And the response is, I'd like to help you. I don't know anything about your data. So we'll use the same prompt. This time we'll ask the database. And I have tables with customer data. And you can see that the response now was actually queried against my customer data. I have the country name and the customer count, and it's placed in descending order. All right, let's ask another question. The next prompt, who are the top 3 baby boomer big spenders? We'll ask the LLM directly. And so it's come back with some general information that the LLM, the knowledge that the LLM has about baby boomers. Now, empty nesters, retirees with high net worth, entrepreneurs. Now let's ask that same question of our database data. And the response shows that it queried my customer data. So we have customer first name, last name, and the total spent. So looking at the explain, the prompt, who are the top 3 baby boomer big spenders, relies on the knowledge of the LLM to know what baby boomer and big spender are. So you can see that the LLM defined the baby boomer by specifying a birth year range, and it ordered the customers by their spending to select the top 3. On the left, we have the SQL query that was generated again, along with a really nice explanation of what it's doing. So using natural language. So it identifies the top 3 baby boomer big spenders by joining the tables that I have and views in my schema. And then it has a step-by-step breakdown of the query. Each clause is explained to you. So this is a really nice way to learn SQL. And so we're achieving all of this through, in the settings, you can look through a profile, and you can have different profiles for different AI providers. I'm using OCI GenAI, but in this profile, it's like this predefined configuration for interacting with our LLM. In addition to the AI provider, you can supply database tables and views for querying and other settings, which we'll go into more detail in my next demo. You can explore this chat app further using a live lab that I'll put the link in the webinar chat. It's called Chat with Your Data in Autonomous Database using Generative AI. And that lab actually created this Autonomous Database instance for me as well. So with that, I'll hand it back over to Mark.
Thanks, Sherry. So we've just seen a nice way of leveraging Select AI in a chatbot. And as we've seen, Select AI allows you to use natural language to query data and get responses using generative AI. It can do this using the LLMs from multiple AI providers. This is not only the one Sherry mentioned, but also the OCI GenAI service, OpenAI, Azure, and Cohere. And recently, we've added Google, Anthropic, and Hugging Face, and there are more options on the way. Now, Select AI provides several actions for interacting with your LLM and your database, and we're going to look at each of these in more detail. As you see here on the right, you invoke Select AI using a standard select statement followed by the AI keyword and one of the actions that we've shown here. But first, what if we don't have Select AI? Now, let's say we're a movie streaming business and want to generate SQL to find our top 10 streamed movies. Now, this is perhaps in contrast to what we saw earlier in the demo, but consider this result from a version of ChatGPT. It gives a decent description and the generated SQL query. While it produced a syntactically correct query, it had to invent or hallucinate the table's movies and stream data as well as their columns. And it correctly performed the aggregation and ordering and skimmed off the top 10 rows. And of course, the problem is that if we tried to run this query on our database, we'd expect it to fail as our tables are likely different. So, how does this work with Select AI? Well, we start with the user's natural language prompt and augment it with the database schema metadata and other instructions. This augmented prompt is provided to the LLM, which then generates the SQL query. And consider the example prompt as we saw earlier, find the top 3 baby boomer big spenders. For this, as Sherry mentioned, we're relying on the general knowledge of the LLM to know exactly what a baby boomer is and how to compute a big spender. And the metadata that we're including is from the tables in your database. And this includes table and column names, their data types, and optional comments. Notice that in the case of generating a SQL query, no actual data from your tables is being provided to the LLM to generate that query. Now, but how do you tell Select AI which tables to use? We might have many tables in our schema, and here are a few that might be part of a movie streaming service. Enterprise customers and applications will often have hundreds or thousands of tables, even in the same schema. And these typically need to be reduced to a select few to limit the volume of metadata sent to the LLM so as to not exceed token limits, while at the same time helping the LLM to produce more accurate queries. Well, we do this using an AI profile. And Sherry gave us the glimpse of that a little bit earlier, but we're using the DBMS Cloud AI package, which supports Select AI. You specify an AI profile with your choice of AI provider, credential object name, which gives you access to that provider's service, the model you want to use, and the list of tables to include for SQL generation. And there are other attributes you can specify, like enabling conversations, comments, RAG, among other features. And we're going to introduce those a little bit later. Now, in this example, the provider is OpenAI, the model is GPT-4o, and the set of tables that you would like Select AI to consider when generating SQL queries are chosen from the movie stream schema. If you're working in a stateful database session, you can set this profile to be used in subsequent Select AI invocations from the SQL command line. When building applications and using a stateless session, use the DBMS Cloud AI generate function, which takes an AI profile as an explicit argument. And we'll show examples of these a little later. It's worth noting that the AI profile makes it easy for you to switch among AI providers and LLMs, as well as other settings, to quickly compare results. And you can create several AI profiles depending on your application or business requirements. Now, in addition to show SQL, there are several other Select AI actions that you can use. The default is run SQL, which takes the generated query and runs it in the database to produce a row set, which is returned to the user. And it's worth noting that Oracle security policies enforce data access rules as for any other SQL query. Now, the narrate action extends this one further by taking your row set and passing it to the LLM to generate a textual description of the query result. It's important to note that narrate for NL2SQL is the one action that sends table data, the result of the query, to the LLM. So, if you're concerned about sending actual data to the LLM, you have at least two options. One, don't use this action, or use an LLM in an environment you feel comfortable with. Perhaps that's OCI GenAI service, or, as we'll discuss in the roadmap section, a private endpoint. And as we'll see shortly, a narrate is also used for retrieval augmented generation. Now, the chat action is a pass through to the LLM where it takes your prompt, passes it to the LLM, and returns the response. You can do whatever type of manual prompt engineering you'd like and invoke that through SQL. In the example, we're using Select AI Chat and using the question, what is Oracle Autonomous Database? So let's see how you set up Select AI and then see how to use it for NL2SQL generation with your database data. Back to you, Sherry.
Okay, so this is Oracle Machine Learning Notebooks, and this comes pre-installed and ready to use with your autonomous database. So let's walk through the setup steps for using Select AI. As the admin user, the administrator, two things are required. Granting DBMS Cloud AI execute permission to my user, my OML user movie stream. And when not using OCI Generative AI, you need to configure secure network access to your AI provider. And these two steps right here were done for me by my administrator. Okay, so the next thing, as the OML user, we'll create a credential to set up API access to the AI provider. I'm using OCI GenAI, and this requires my credential name, my autonomous database user and tenancy IDs, a signing key, and a fingerprint. Recall in the chat app, we selected the profile. We're creating that here. So you specify the attributes in this profile configuration. Some are optional: the AI provider, your credentials, the database tables you want to query, and whether to enable the conversation history and include comments, which is additional metadata sent to the LLM to help it construct more accurate SQL. And I also provided a profile description. So after the profile is created, we set the profile, and now we can start chatting with our database. Okay, so this query is running with the chat action. This submits the prompt, what is Oracle Autonomous Database, directly to the LLM. There's no interaction with your database data, and you can see that the response is like a detailed explanation about Autonomous Database, including some key features and benefits, use cases, and a summary. Now we're going to use the conversation history to find out when it was released. So we're asking a follow-up question. And the response is going to indicate that the LLM inferred that we were referring to autonomous database when we talked about it. So our chat history is preserved. Show SQL. This returns the SQL generated from the natural language prompt using the database tables and views that we specified in the profile. And you can see that customers is referring to the appropriate table and column references. The run SQL is the default action, so I don't need to provide the run SQL action in the query, and it generates and runs the SQL query generated by the natural language prompt, and then runs it. And so I see my total customers as a result. Now, run SQL, how many are in each country and placed in descending order? Well, how many customers are in each country and placed in descending order? And here's my result. I'm using the bar chart, but you can also look at the raw table data if you'd like. So I have the number of customers by country. And now, continuing the conversation history, we are going to add to that the number of males and females in each country. And I can see my total customers, males and females. And this is the same prompt that we used in the chat app. Find the top 3 baby boomer big spenders. And that's obviously querying my customer data and returning the same result. Narrate. So with the narrate action, the result of the SQL query is provided to the LLM to produce a narration or a textual description of the data. And we see that the top 3 baby boomer big spenders are listed in order. Show SQL is returning the SQL that's generated by the prompt. We saw this in the chat demo where the LLM is inferring that baby boomers are born between 1946 and 1964. And then again, the explain SQL returns the SQL query with a detailed explanation what that SQL query is doing by clause with notes and a summary at the end. So as we've seen here, Select AI really simplifies the process of querying your database. It's pretty exciting. Okay, Mark, over to you.
All right, thanks, Sherry. So, as you might expect, an LLM is in part limited by the quality of the metadata it receives for generating runnable SQL. And consider, this pathological case where our tables are just called generically table 1, 2, and 3, and our columns are equally generic. If we simply ask the LLM a question against this schema, it will have no idea how to formulate a query. But if we define comments on our columns, this information can be added to the table metadata that's provided to the LLM, so it can be more likely able to generate runnable queries, in this case against our specific movie stream schema. And even when tables and columns are reasonably named, adding such metadata in the form of comments can be a significant asset. And this is just one of the ways that you can tune your schema to help the LLM produce better queries through Select AI. Now, another feature of Select AI is the use of conversations for chatbot-like behavior. When enabled, Select AI remembers up to your last 10 prompts and adds them to the current prompt. And you can use this with chat, but also for data exploration. You ask a question, review the response, and follow up with more questions to refine the result without explicitly re-specifying previous prompts, typical chatbot behavior. So let's see an example of each. On the left, you see how we enable this with the attribute conversation, which is set to true. On the right, we ask a question about what is an autonomous database using chat. And in the second prompt, we ask when was it first released? So with conversations enabled, the LLM can give us a meaningful response. Now, when it comes to conversations for data, we can combine this with the object list when we use run SQL and other NL2SQL actions. Using our movie stream database, we might ask what are our total streams, break that out by genre, add a customer segment, and then keep the top 5 customer segments and genres by total views. So here's a brief demo that illustrates using the conversation feature for iterative refinement. We start with our total streams, and we see we have about 2.5 million of these. We might want to break that out by genre. And we see the total stream count for each genre of movie. Add a customer segment. So this is tying into our customer data. And then let's keep the top 5 customer segments and genres by total views and include a rank. And finally, let's understand what the query is that enables this. So if we scroll up to the top, we see the query itself and an explanation of what that query is all about. All right, so let's move on to a use case where you provide a custom prompt with details from a customer database table. Now, let's say you want to generate a personalized email with activity recommendations for a vacation destination specific to your customer. We have the context from our database in the form of customer information, demographics, and their interests. And we might have another table with various tasks or prompt instructions, like recommend 5 great things to do at a location. And we construct our prompt to generate a personalized email using the general knowledge of the LLM. And finally, we submit that prompt to the LLM using the Select AI chat action to get a compelling personalized promotion, complete with emojis. Now, to go into a little more detail for developing such an application, we might have a customer table and a project table. We select a particular task and the rules for completing that task for an individual user with their demographic data. And we join these two tables to get the results shown here. Now, using the database feature JSON object function, we can convert this result into a JSON string. That's an easily digestible format for your LLM. And here we're going to use the generate function I mentioned earlier to make a chat request to the LLM using our profile with our custom prompt. And of course, here's the response from the LLM describing exactly what we requested, complete with emojis. So this brings us to Retrieval Augmented Generation, a feature of Select AI that is available with Autonomous Database 23 AI. The purpose of RAG is to give the LLM new knowledge, addressing some of those limitations we talked about earlier, but without requiring LLM fine-tuning. Select AI seamlessly integrates AI vector search, another 23 AI database feature, and automates the orchestration steps for vector index creation and the RAG workflow. This greatly simplifies your ability to leverage RAG. But before we get too far into the RAG details, let's briefly talk about vectors and semantic similarity search, since that underpins what we're able to accomplish here. We know that databases are great at querying business data that's stored in neat values like strings, numbers, and dates. However, databases typically haven't been as good at querying unstructured data like text, images, and video, especially where exact or fuzzy matches are insufficient. Now, semantic similarity search, introduced in 23ai's AI vector search, makes it easy to query that type of content using semantics, or meaning, captured using vectors, as opposed to exact or fuzzy match. Now, a vector is a sequence of numbers called dimensions. And these represent the semantics of unstructured content, like text, images, or video. And you can create vectors for an object by using what's referred to as a transformer or embedding model. With AI vector search, there's a built-in function for vectorizing content using a transformer that you specify. The transformer can be an AI provider or imported for use directly in the database. Now, with 23AI, you can store these vectors in a database table and use powerful vector indexes to find similar vectors at scale. Now, this semantic similarity is determined by the mathematical distance between two compatible vectors. Vectors are compatible if they're produced by the same transformer and have the same number of dimensions. Now, AI vector search supports multiple distance functions, and here we're showing the Euclidean squared distance computation. So this brings us back to retrieval augmented generation. This technique uses content separate from the LLM and often private to augment user-provided prompts. Here, RAG combines the semantic similarity search using vectors and an LLM. RAG enables LLMs to use business data to produce better and more accurate responses without fine-tuning, which might require using your business data, leading to possible security concerns. So here's a simple example illustrating the RAG technique where a separate vector database is used to store and search for related vectors. In this scenario, we're using text documents containing the text from Oracle machine learning blogs to get authoritative answers to user questions. Now, we might start with the prompt, what does Oracle machine learning support? But our chat history also indicates that we were talking about data and model monitoring. So let's use this prompt conversation and feed it to the transformer to generate vector embeddings. Now, these vectors are then used to perform semantic similarity search on the pre-populated vector database to find matching vectors. And we retrieve the relevant text chunks from our database and produce an augmented prompt that then is sent to the LLM with the goal of producing a more accurate response. Of course, AI vector search allows us to have the vector store as well as the relational database in the same component, simplifying the overall architecture. Select AI goes one step further and automates this entire process, including the production of the vector store itself. So let's take a quick look at that workflow. The first step is to create your vector store from the documents you have in cloud storage. Select AI retrieves these documents, chunks them to produce vectors, which get stored in the vector store, and then produces a vector index that can be used for RAG queries. Now, since our vector store is in the database, we really just have a single component, autonomous database. Now, as I mentioned earlier, you can use a separate API provider for the transformer, or you can load an ONNX format transformer to use in the in-database ONNX runtime. And this is a feature of Oracle machine learning and also exposed in AI vector search. To create a vector index using Select AI, you first create an AI profile to specify your AI provider and a transformer or embedding model. And then you invoke the create vector index procedure, where you specify your vector index and various attributes, like the vector database provider, which is Oracle, since we're using AI vector search, the location of the text documents in object storage, along with the credential to access them, and the name of the profile we just created. And you can specify other attributes like chunk overlap and chunk size, but there are defaults provided for these, so you don't necessarily need to specify them. Now, to enable invoking RAG, we create an AI profile that specifies the vector index we just created, the LLM that we want to use, and the transformer. And if we'd like to see which source documents were used as part of the RAG process, we can enable sources as well. Now, for the second step, here's the process flow. With our vector index available, the user asks their question using the narrate action. Select AI then sends prompt chunks to the transformer to generate vectors used to search the vector index and retrieves the top results. It then sends the augmented prompt to the LLM, which returns the generated result. And as before, you can use your own AI provider or leverage in-database ONNX runtime for your transformer. Here's an example using Narrate to answer the question, what type of monitoring is enabled in Oracle machine learning? We see the response that there are two types of monitoring, data and model monitoring, with a description of each. And note also that we have the sources, which include the document file name and the URL to that document in object storage. Now, if you'd like to see the data chunks as well as their similarity score, you can use Run SQL as shown here. And this provides a table with one row for each chunk. So let's see a brief demonstration of Select AI using RAG. Sherry?
Okay, so we start by creating another profile for RAG for processing our natural language queries. Our default LLM and embedding model is shown here. And if you have imported an ONNX model to the database for creating embeddings, you can see the two Hugging Face models that I have. You can change the embedding model from the default using a set attribute as shown here. Okay, I'm going with the default. So next, I create a vector index whose source is the blog files that Mark mentioned that are in the object store that I'm pointing to in this location attribute. The other attributes include my profile, the distance metric, which is cosine, chunk size, and others. So I can look at the attributes for this vector index, my vector index, and I can see the vector database provider is Oracle, that location, information about my object storage, profile name, the distance metric, and then I can look at the actual table corresponding to that vector index. So my vector index, vec tab, and then I can look at the contents of that table, the first 4 rows. So the first 4 chunks, you can see the content from the blog, attributes like the object name, size, the location URI, and then the embeddings. Then, once I set the AI profile for RAG, I can start asking questions. So here we're asking what type of monitoring is enabled in Oracle Machine Learning using a narrate action. And when the response comes back, it's going to also have the sources of the content, which are those text files that we have in object storage. So here's the response. Oracle Machine Learning has 2 types of monitoring, data and model monitoring, along with the sources that it used to get that response. Run SQL with the same prompt. And this is going to return the content along with the source, the URL, and the associated score. So here is the content retrieved, the source of that content, and the URL. So that query ran in the background and returned that results to us. Finally, using Generate for stateless invocation. Mark went over this in his slides. We're using DBMS Cloud AI Generate, and we can pass the prompt, our profile name, and the action that we want there. And so this is used in stateless environments. For example, the Apex app that we showed earlier, SQL Web worksheets here in Autonomous Database, those are stateless environments. And so you would use Generate to run, use Select AI in those environments. And here is Generate with the run SQL action. We get back the responses in JSON format, which I've pre-printed here so that you can see we get the data, the source, and the URL. Okay, Mark, back to you.
Okay, thanks, Sherry. So another Select AI feature is synthetic data generation. And the goal is to generate realistic test data with the help of LLMs. And this can help jumpstart new projects where you don't have data available, allowing developers to validate the user experience and test software and interfaces. It can also address scenarios in which sensitive production data can't be made available to the development or QA organizations. So here's a simple example generating synthetic data for a single table. You invoke the generate synthetic data procedure using a new or existing table, possibly with sample rows. Specify the AI profile, the table that you want to populate, and how many records you'd like, and an optional user prompt that can direct the LLM about the type of data you'd like. Now, if the table contains data already, a subset of the table rows will be used as examples to help the LLM generate more relevant content. On the right are rows from our director table that were generated. Now, another scenario is where you have multiple tables, possibly with referential integrity constraints, and you want to generate data for each. Now, here you specify the table names and the number of records you want, along with an optional additional prompt per table. In our example, we want movies released in 2009, and you can see some results on the right. Now, one of the use cases for synthetic data generation involves an autonomous database metadata clone, which is a new database that has the same schema metadata as the source database, but doesn't include the data. Now, to achieve greater scalability, Select AI leverages parallel jobs to interact with the LLM and perform bulk inserts. And you can increase your autonomous database eCPU counts to enable greater parallelism. Now, we've been talking about several features that have been introduced at last September's Cloud World, like RAG and synthetic data generation. So let's look at a few more recent ones. Most notable is the availability of Select AI for non-autonomous databases, as I mentioned earlier. Look for this in the release 23.7 as it becomes available for your specific database. It's important to note, though, that 23.7 Select AI enables natural language to SQL generation only. It doesn't include RAG or synthetic data generation. That's coming. A second feature, which I also mentioned earlier, provides the ability to use imported ONNX format transformers through the in-database ONNX runtime. This soon-to-be documented feature can be enabled today by prefixing your transformer name with database : to indicate that this is an imported model. Now, we've also added several AI providers since Cloud World. As I mentioned earlier, these include Google Gemini, Anthropic Claude, and Hugging Face, which supports a wide range of models like Mistral and DeepSeek. Now, see the documentation for details about using different AI providers in your AI profile. So next, we're going to talk about the Select AI roadmap. You were probably wondering if we'd enable RAG and synthetic data generation on non-autonomous database instances, and these and other features are going to be included in the 23.8 release. Now, a new top-level feature in Select AI is providing conversation management for creating, deleting, and loading conversations, and this will greatly help with application development. I'll say more about that in a bit. But let's look at some roadmap items in each of the categories listed here. So on the roadmap for NL2SQL, we have support for the 23AI feature annotations, which can be included in the table and column metadata provided to the LLM. We'll also augment metadata with foreign key constraints to further help the LLM determine relationships among tables and views. All of this with the goal of producing more accurate SQL queries and results. Now, because case sensitivity for value retrieval can be an issue when generating queries, you'll have the option to enable case-sensitive comparisons, with case-insensitive being the default. We'll be providing a historical view of past Select AI prompts and responses, and support for using metadata from analytic views. A frequent request has been the ability to handle schemas with many tables by automatically determining which table metadata should be included in the augmented prompt. That's a question we had in the Q&A already. And another key request has been the ability to provide feedback and corrections on generated SQL to improve augmented prompts sent to the LLM. So I'm going to say more about large schemas next, and then we'll come back to talk about feedback towards the end of the session. Now, for handling large schema metadata, Select AI will automate and optimize the selection of schema objects based on the user prompt. The goal is to significantly reduce metadata sent to the LLM while focusing on the most relevant schema objects that can support the prompt. And this eliminates the need to explicitly specify your object list or to have multiple AI profiles with different subsets of tables, depending on your business needs or specific use case. And this leverages AI vector search with the transformer defined in your AI profile. So essentially, Select AI is going to vectorize the metadata of your schema, which can also be automatically updated to reflect schema changes per a settable refresh rate. Now, based on vector similarity, Select AI retrieves the metadata for the most relevant schema objects. And you can adjust the number of tables you'd like considered along with the similarity threshold. And this will be enabled in your AI profile using the object list mode set to automate it. Now, on the roadmap for RAG are also much requested features. The most frequent is support for PDF and PowerPoint files when creating the vector index, and this will be coming online relatively soon. We'll also be providing chunk offsets in the source listings so that application developers can easily identify what text in the document is being cited. And we'll enable multimodal LLMs and transformers that support images as well as text. Another important feature is enabling hybrid vector index search, which combines all the information retrieval capabilities of Oracle text search indexes with the semantic search capabilities of AI vector search indexes. We'll also be enabling the use of graph analytics in combination with RAG. And regarding source documents for RAG, today your documents must be stored in cloud storage like OCI, Azure Blob Storage, and AWS S3. But we'll expand this to enable vector index creation from database table columns. This is particularly applicable where we have unstructured text as well as images stored in tables. And currently, your AI profile can specify a single document source. And this enhancement will allow for multiple document sources to be specified. And we'll even provide more document source options, including directory objects like NFS, Google Drive, and SharePoint. Now, enhancements for the AI profile include enabling specifying the chat history length and retention for conversations. And this also ties into the conversation management API I mentioned earlier. We'll also provide an option to allow you to restrict tables to those that are explicitly listed in your AI profile. This ensures the LLM doesn't errantly include tables from the broader schema or system that you may have access to. And currently, you create a separate AI profile depending on whether you want to use NL2SQL or RAG. And this third feature enables using a single AI profile that enables both SQL generation and RAG. Select AI uses the LLM to help determine where best to get the answers depending on the prompt. Now, regarding the conversation management API I mentioned, this facilitates building ChatGPT-like chatbots, where you can persist and load named conversations across sessions. You can provide conversation names manually or have the LLM generate them for you. And using the retention period attribute, you can indicate how soon to automatically delete a conversation after its last use. And this feature also facilitates using conversations with Oracle Apex. On the right, you see API calls, including resetting a conversation to remove any chat history, as well as to begin, delete, load, and list conversations. And we'll even have a view available that returns to the row set of existing conversations to make it easy for you to view those. Now, regarding AI providers, a much requested feature is the ability to support privately hosted LLMs using OLAMA over private endpoints. And to enable this, you'll specify OLAMA as the provider and your provider endpoint in your AI profile. You must also alter the database property root outbound connections to enforce private endpoint. Now, on Autonomous Database, this leverages OCI compute resources, or in the case of multi-cloud, you can leverage some of the other multi-cloud providers for that, like Azure NFS. With 23.7 for non-cloud database instances, you'll use a similar approach for privately hosted LLMs. Now, moving on, we plan an autonomous database provided LLM with a kind of default model that can enable users to try Select AI without first having to establish an AI provider account. And finally, we'll also enable other providers like AWS Bedrock, as well as the broader access to models from OpenAI compatible providers. There are a few new actions on the horizon. Summarize. This will make it easy to generate a summary of long text from the LLM directly through the Select AI interface. The feedback action enables user feedback on generated queries to help improve result accuracy, and I'll explain more about that shortly. The embedding action returns the corresponding prompt's vector embedding produced by the transformer for certain use cases. Show prompt. This is one that returns the augmented prompt that was generated by Select AI. And lastly, admin to assist with database administration. Now, regarding the feedback for prompt tuning, the goal is to improve the accuracy of the generated SQL. And this feature enables users to provide feedback on generated queries, helping to improve the LLM's SQL generation performance over time. Users can provide feedback in a variety of ways, including easily adding your feedback on the last Select AI statement that was run, as shown here on the left. Alternatively, you can use the DBMS Cloud AI feedback procedures to provide such feedback and have that factored into Select AI's process. Now, the last roadmap item I'll mention is AI for admins. This leverages the new Action Admin I mentioned earlier. The objective is to simplify database administration using AI. For example, troubleshooting SQL performance, identifying application bottlenecks, and even monitoring database resources. And this uses the LLM to categorize user questions, which Select AI then uses to determine specific prompt instructions provided to the LLM to generate a response. And here's an example, where we're interested in finding issues with queries on our employee table. And we see in the response that there could be an issue related to the cost-based optimizer system statistics. It makes a recommendation to gather statistics and how to do that. So for more information on Select AI, here are some resources, and this includes various blogs and product documentation. You can check out the Oracle Live Labs, which provides you with step-by-step instructions on getting started with Autonomous Database and Select AI. And there are also some videos, resources that you may find useful. So thanks for joining us for this session on getting started with Select AI. If you haven't already, consider subscribing to the series. You can use the QR code shown here. Thank you very much for attending this session, and we look forward to seeing you at future sessions.